Alrighty, good morning everybody, hope you're doing great. Here's what we got going on today. So as you can see, we're diving right into Unit 2, and we kind of pick up where we really left off in Unit 1 in terms of translating verbal expressions, from, words actually into, something nice and fun, kind of like something like I've written over here. Alright, so some vocab today. Formula is a really fancy word for an equation, right? An equation, just a mathematical sentence that's got to have an equal sign. Expression is just what we see over here. It's just some combination of numbers, which we call constants, and variables. And then we have some operations, thrown in between all of it. So formula, as we see here, though, right, it's basically, like I said earlier, a fancy equation, and it just shows us a relationship between whatever we have, right? It can be between a variable and a constant, between a couple variables. Regardless, though, in a formula, we are going to have an equal sign, right? So we will see an equal sign in there. So that's what we're going to work on today. We're going to be translating some sentences into equations, as well as translating equations maybe back into sentences, and so on and so forth. So let's enjoy the show and let's get right to it. Okay, translate this one into an equation. A number b, so it's actually telling me what it wants me to use, right, for a variable, right? It says a number b. There we go. Then it says divided by 3. So we're taking b and dividing it by 3. All right, I think we can make all of this look like a fraction. All right, I know we could write b divided by 3. Okay, this is the not so great math way. All right, we need to start using fractions, because fractions show us division, and this is the grown-up way, all right, to do this. So there's b divided by 3. Then it says is equal. Okay, there's your is equal to 6 less than c. All right, again, this is what we did in Unit 1. 6 less than c, right? Who's doing the subtraction? Are we subtracting c or are we subtracting 6? Order makes a difference in subtraction. So this one is c minus 6. There we go. Unit 2, gang, all about equations. So we're going to solve all sorts of equations, linear equations, nice equations. But first we're going to write them, right? Then we'll get to solving stuff like this here later on this week and next week. All right, here's another one. 15 more than z times 6 is y times 2 minus 11. All right, we got a lot going on here. Is, right, this is kind of like your breaking point. Is, of course, means equals. All right, so here is the first half, all right, of our equation. Right, here is the second half of our equation. So 15 more, right? 15 more, so we should be thinking add, right? 15, just like that. Z times 6, right? Z times 6. Now you could write Z times 6 like, hey, Z times 6, right? Just like that. But let's be grown up and just say, hey, 6Z. So 15 more than Z times 6. All right, is, of course, equals, and then here's the second half of our equation, the right-hand side. Y times 2 minus 11. Y times 2, so there we go, minus 11. That was fun and awesome. Okay, here. All right, translate this one into an equation. A number c multiplied by 6 is equal to 2 more than d. All right, so again, if it helps you find the breaking point, right? Here's is, all right, so there's my equals, and then, all right, we've got this part, and then we've got the other part that actually stretches down over here as well. So left-hand side, number C multiplied by 6. All right, we'll call that 6C. Equal to 2 more, right? So we should think to our head plus 2, then D, right? And when they are specific about the variables, let's go ahead and use the ones that they would like. So D plus 2. All right, that's all we got there. Okay, translate this sentence into an equation. 3 less than a number A divided by 4 is 7 more than 3 times B. This is a really, really tough one. All right, so read that first sentence. Here we go. 3 less than a number A divided by 4. All right, here, let's get the easy part out of the way. Is 7 more than 3 times B. So there's your is equal 7 more, right, plus 7, 3 times B. That's the easy part. Let's really focus in here on what's going on with this left-hand side of our equation. 3 less than a number A divided by 4. So here's the key part. 3 less says subtract 3. Right? This says to me you are going to subtract 3, and whatever's to the right of this or whatever comes next in our sentence, that's what we're going to subtract 3 from. Well, it's a number A divided by 4. So write A divided by 4. Again, fractions, people. Fractions. A divided by 4. 3 less says minus 3. Alright, so again, that's what this one looks like. You really just have to be a good reader and don't try to throw everything together. But there's what we like. Again, fractions show us division. So when we see divided by, let's try to write a fraction at all costs. Okay, here we go. Jelly beans, everybody's favorite. A jelly bean manufacturer produces, that's a lot of jelly beans, 1,250,000 jelly beans per hour. How many hours does it take them to produce 10 million? Woo! Okay. All right, so we're going to write a formula to, I guess, solve this problem. So here, look, think. We know this place makes, 1.25 million jelly beans an hour. We want to know how many hours it's going to take them to make 10 million. So we're going to have to write an equation that helps us, solve or represent this scenario here. We're going to pick whatever, I guess, what are we trying to figure out? We're trying to figure out how many hours, it takes. So I'm boring when it comes to variables. Let's just use H for hours, okay? So we're going to use H for hours, and we'll make an equation that has H in it. And H, is how many hours we're going to need to make all, I guess, 10 million of these jelly beans, right? So we know we make this many per hour, right? In 1 hour we make this many. Our goal or our target is to figure out how long it's going to take to make these. All right, hopefully you're formulating a plan inside your head. Basically we're going to take this incredibly large number. Let me write this out, right? So 1.25 million, and we make that many an hour. So I'm going to put an H on the end of that. And we want to figure out how many hours, right? Because if we make 1.25 million, it's got to be times some amount of time of hours where it will equal 10 million. You know what I mean? So there's your fancy equation. So there's some amount of time that we can multiply by 1.25 million that will then equal, right? That will then equal this, 10 million. I'm sure a lot of you are already getting your calculators out and dividing. This is a basic one-step equation, right? We're not going to even worry about solving these. This is lesson 2.2 is solving these equations. We really just divide both sides by that 1.25 million. And I don't know that it asked us to, but we can say, hey, it's going to take 8 hours. Right? I think a little bit of division there helps us out. Take about 8 hours to make 10 million jelly beans. That's just all in a day's work, people. All in a day's work. 10 million jelly beans. All right, here we go. Translate the sentence into a formula. The perimeter of a square equals 4 times the length of a side. Okay. So perimeter equals blah, blah, blah. Okay? So perimeter of a square equals 4 times the length of the side. So again, at no point in time does it tell me what variables to use, so I'm boring. So we'll use P to represent perimeter, and that is equal to 4 times, so multiplication, 4 times the length of one side. We'll just call, do we know what the length of the side is? No. So we'll just call that 4 times the length of the side. I'll use S. Right, so there you go. Again, pretty straightforward, pretty easy. All right, translate this one into a formula. Area of a circle equals the product of pi and the square of the radius r. Again, some of you probably know this formula by heart. All right, but if we don't, and a lot of times you'll see these problems just embed the formula into the problem and then make us figure out, area or whatnot. So area of a circle, right? Here's our first part. So we'll just say area equals, there we go, and product of pi and the square of the radius r. So product of means we're going to multiply two things together, and then they list them for us. Pi and the square of the radius r, meaning we need to square the radius and then multiply that by pi. So we've got two things, pi and the radius squared, and we're just going to multiply them. And I know sometimes we have the multiplication dot in there, but we really don't need it, right? And I know we're all familiar with just area equals pi times the radius squared. Don't worry, we're getting closer to the end. Translate the equation into a verbal sentence. Okay? So let's go ahead and translate the first part here. We can be as simple, and there's more than one way to do this, but we could be as simple as just saying, hey, 12 minus, 2, I was going to actually write it 2, 2 times x. All right, that's easy enough. Then we could say is equal to, and they've really made our life simple. We just have a number here, equal to -5. That's in my best handwriting for all of my handwriting experts out there. You know who you are. Okay, sweet, that was fun. Let's go to the next one. Translate the equation into a verbal sentence. Ooh, they've really spaced this one out here. So again, we just need to break down each part that we see, right? So this is a to the second power. So you can say, a squared. You could say a to the power of 2. Those all work. Then we could say plus 3b. How can we say 3b in words? The product of 3 and b. Let's go with that one. The product of 3 and b, just to be different, is, all right, and then here we go. Let's say a number c divided by 6. There you go. So a squared plus the product of 3 and b is a number c divided by 6. In my best handwriting. We're getting close to the end. Don't worry, only. Alrighty. Translate the equation into a sentence. All right, once again, more translating. So, again, this one's got a lot going on here. Ooh, that was kind of fun. This one's got a lot going on the left-hand side of our equation. All right, so let's really slow down and do a good job here. So, 12 and B. So let's just say ELVE. There you go. Ooh, 12. No, that is not how we spell divided. There we go. So 12 divided by a number B. Then we could go easy. Minus 4 is negative 1. Why is this moving? Ooh, okay. Let's see if we can't move that back over there. There you go. That was cool. Okay. All right, so there's that one. Moving. And all good things must come to an end, folks. I apologize. So here's our last one. 5a equal to b squared plus 1. All right, so last time we said, the product of 5 and a. I know we can also say, no, we have to write it. 5 times a, let's say, is equal to, and then we just got to take care of the right side, b squared plus 1. So let's say b to the second power plus 1. We wrote the addition kind of boring. I'm sorry. Anyway, so I think there we go. So we're good to go here. Again, today's all about writing, translating, right? These, sentences, equations into and out of words. So very similar to what we did before. So it shouldn't be anything too crazy. So as usual, right? Here's your thing. So now, my people, let's go on to the book practice. All right, and you see the pages up there. Then you're going to move on, right, to the self-check. And if you get done with those two things, you can show them to our substitute. And then if both of these look amazing, they will give you the homework, and you can get a start on that. If not, everybody will get this, all right, at the end of class. So be your best you, all right, and I'll see you guys tomorrow, okay? Have a great rest of the day, guys. Later.